All right, in this segment, what we're looking on is an aspect of mathematics that is called transposition of formula. In transposition of formula, we're going to realize that it is very similar to solving. It is very similar to solving an equation. So if at all we know how to solve an equation, like a regular equation, then the idea is the same as it relates to transposing. It's solving an equation. So there are key things that we always have to do when we are transposing. Well, firstly, we need to understand what it means to transpose. Well, what it means to transpose is to make something the subject. And when we say the subject, we're referring to the main idea. Make something the subject. Make it the main idea. In other words, it is going to be isolated. So when we make something the subject, then this comes into play. It's isolated. Isolated. It's by itself. All right, so we have to isolate that. All right, so that's what we refer to, making something the subject of the formula. We want to isolate it by itself. Another thing that you take into consideration, which is very key, is what we call to balance, right? We have balancing and we have the inverse operation. So let me just write them. Inverse operation is very crucial, because if you're going to be solving for something or making something the subject, inverse operation is crucial. We have to know the inverse operation. What do I mean? Well, if you're adding, the inverse operation of adding is to subtract, and vice versa. Subtraction is to add. If you're multiplying, the inverse operation of multiplication is division, and vice versa. Division is to multiplication. Also, if you have a square, the inverse operation of the square is going to be the square root. And then if you have the square root, the inverse operation is the square. So, and then it depends on the level of root that we have, third root, fourth root, fifth root. The inverse operation is to use them against each other. So we have to understand the inverse operations, and then while using the inverse operation, we have to balance. This is key, because whatever we do on one side, so whatever we do on the left hand side must be done on the right hand side. And if we just look at these as we go through, then it's going to be, you know, a nice little task. All right, let us now start with some very simple ideas first. Let's start with some simple ideas. Let us say, what if we have A plus B equals C? And I'll say let us say for A. All right, so A plus B equals C for A simply means that we want to isolate the A. In other words, we need to make A the subject. Now, if you look right now, the subject of this formula is C. Why? Because it is isolated by itself on the right hand side, and the other things are on the left side. If I want to make A the subject, then A must be alone, so I'll just leave A on this side. First thing I do is to observe A is on the left side, but there is something else going on. There is a plus B. So it is my intention to cancel or to zero pair out this plus B. How do we get rid of this plus B? Well, you get rid of plus B by simply subtracting. What's the inverse of a plus B? The inverse of it is a minus B. Right? And then whatever is done on one side must be done to the other side. Right? So we have a minus B on both sides. But in this case, this would have cancelled itself, and that is why it is done. So now the A is isolated, and A is equal to C minus B. So now you could see that when we started out, C was the subject of the formula. And then as soon as we made a few moves, then A is now the subject of the formula. It is isolated and it is by itself. So basically, anything that we intend to cancel out, we have to first see what it is doing and then do the inverse to it and balance. Let's look on another case. All right, so what if we're looking at, say, 3D is equal to m minus, say, y, and I want to make m the subject. At this moment, 3D is the subject. I intend to let m be the subject. So let me circle that. So I put a box around this. I want this to be the subject. But when you look on the side that it is on, there is a minus y on this side. So because there's a minus y on this side, then my intention is to zero pair out this, which is to let this become 0. Let me get rid of this fully. This is a minus y. How do we cancel a minus y? Well, we get rid of a minus y by adding y, because it's a negative y. So if I use a positive y with it, it's going to cancel out itself. But whatever I do on one side, I have to do the exact thing on the other side. So I would have to add y to the right hand side. Now let's simplify. When we simplify this, we're looking at 3d plus y is equal to m. So now you could see that the m is now by itself and everything else is on the other side. And that's what we mean by transposition of formula, to make m the subject of the formula. All right, let's go further and look at some more things. What if we have a case where we saw, okay, we saw mx minus y equal to, say, q plus r. Now if I look on this and I want, say, for x, I want to let x be the formula. There are a number of ways we could do this, but some of the simplest ways that we could approach this is to leave the subject and anything directly attached to it for last. So we're not saying that this is the only way it can be done. We're saying that this is like the easier way. So we'll isolate these first. So in this case, I need to remove this. How do I get rid of a minus y? Well, I can get rid of a minus y by adding y to the left side. Whatever I do on one side, I have to do the exact thing on the other side. So I'm going to add y to the other side. So now let us look at this. This is now mx, which is now equal to q plus r plus y. Remember, the aim is to isolate the x, so we need to see what's going on. What is going on here? This is a m times x. Therefore, the inverse of what m is doing is to divide. So m is multiplying, then the inverse would help us to cancel m. So we divide by m. So the m cancels itself there. You balance by dividing this side by m. So if we should write this back finally, x is equal to q plus r plus y all over m. All right, so you could see right there we have m x becoming the subject of the formula. All right, let's look on, probably one more case quickly. All right, let us say we look at another case. What if we have a case where I'm seeing y squared plus 3 equals to, say, 4m minus w, and I want this for y. Now the intention is that I'm going to leave the subject and anything directly attached to it for last. So I'm not going to try to get rid of the square root right now. What I'm going to do is I'm going to leave this for last, get rid of the positive 3, and then I see what's next. So in getting rid of the positive 3 minus 3 would cancel it. 4m minus w, but whatever I do on one side, I have to do it to the other side. So I did minus 3 from this side. So I'm going to have to minus 3 from that side. Now you'll see that this cancels itself. Now we're looking at y squared is equal to 4m minus w minus 3. Now you could see that this is y squared. Y squared. Now the inverse of a square, I need y. The inverse of a square is a square root. So I would have to use a square root on this to cancel the square. And whatever I do on one side, I have to do it to the other side. So I have to use the square root and everything over there. Now the square and the square root on the left side would have cancelled out. So we have y is equal to the root of 4m minus w minus 3. So there we have it, making y the subject. Y is equal to the root of 4m minus w minus 3. All right. Basically, let's do the last one. All right, what if I saw a square root sign? For example, I saw a square root of x plus m over n equal to, say, d, and I want to make m the subject. All right, quickly, we want to look to see what's going on. M is under the square root, but I'm not going to touch the square root now. But yes, I could touch it, but I'm not going to touch the square root because I see that the denominator is not under the square root. So I'm going to get rid of my denominator first. How do I get rid of the denominator? If you notice, this is n and it is dividing. So it is the root of x plus m all divided by n. So if I do the inverse of what n is doing, it could cancel the n. So I'm going to multiply by n over 1. Whatever I do to one side, I have to do it to the other side. So I have to multiply this side by n also. Now we could see that this would cancel itself. Let's rewrite what we have. We have x plus m, which is now equal to dn. All right, because d times n is dn. Now I want to access the m, but it is under the root sign. And this is when we're going to employ the square. What's the inverse of a root? The square. All right, and whatever I do on one side, I do it to the other side. So I have to square the other side. So now the square and the square root would have canceled. Now I'm left with x plus m, which is equal to, you could leave this as dn all square, but because these are multiplying, I'm able to say dn, to say d square n square. This is the same thing as that. All right, so in this case, I have one last move. I need to have m by itself. So it means then I need to subtract x, because this x is adding. So I subtract x, and I subtract x from the other side. So now, when you simplify this, you'll see that we have m is equal to d square n square, and this minus x. All right, we're going to stop there for now. And you could just continue to subscribe, watch for more. Thank you.